the recording. Alternatively, I can, so let me rewrite this, 72 divided by 98. Can you simplify 72 and 98? Well, first thing first, you divide it by 2, right? You can, 72 divided by 2 is 36. 98 divided by 2 is 49. And then I don't think you can simplify any further because 49 is, and 36 doesn't have any common factor. And then you break it apart and then you use this rule, you break it apart. Square root of 36 divided by square root of 49, which is 6/7. Which way you like better? I don't know about you, I like the blue top part. It's less thinking for me. I don't have to think about 72, break it up into something, and 98, break it into something. Usually I use this one. If you want to use the red method, it's fine. All right, 24 and 81. Is there a common factor? Is there a common factor? I'm gonna use blue because I'm doing the blue method. Is there a common factor? 24 is, can 24 divided by 3? Yes, right. So you can simplify. So 24 divided by 3 is what? Is it 6? No, 8. Yeah. And then 81 divided by 3 is 27. Oh, this is a cute root. And now nothing. Now you cannot simplify further. So you break it apart. So cube root of 8 divided by cube root of 27. What's cube root of 8? Yeah, 2, right? If I'll do one more step, cube root of 8 is the same thing as 2 cube, which is, remember the Wood method? You kick that little exponent over, right? 3 divided by 3 is 1, so 2. And then cube root of 27 is same thing as 3, so 3. You try number 4. I'm sorry, you try number 3. Put your answer in the chat for Zoomer and for people here. I'll walk around and see how it goes. Does anyone here have a scissor? No? Okay. It's okay. Some game I want to show you in a little bit. Right. Everybody watch the end game? Yeah, I assume you do. Such a big movie. Yeah. All right. Yeah, simplify it first. I don't know the answer. Yeah, it looks about right. Yeah. Okay, so you simplify it with 4.
Yeah. Oh, 96.
Yeah, I mean, the common factor is 6.
Right.
Yeah, so 6 divided by 6 is 1. 96 divided by 6 is
6.
yeah.
So you don't, okay, divided by 4.
For this part, it's like that's how you will talk.
Just have it
very, very
simplified, okay,
simple.
perfect.
Yeah, have to simplify. That's the answer for this one, was it right? Yeah. 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 Very good. One more step or two more. Yeah, almost. You can simplify the forward of 1. Zoomer, you guys have an answer yet? Just give me the answer. I don't need the whole word. Okay, so people here, they got 1/2. It looked like it. So first, I'm gonna simplify it. So the between 6 and 96, I have a common factor, which is 6, right? Maybe this one I do a little bit slow. So I have 6 on the top. On the bottom, I have 6 times 16, and then I can cancel now. I don't know, it makes you confused. Just try to give you a little extra step. You don't have to show me that little step. On the top, leave me 1, right? On the bottom is 16. And then you can break it apart using quotient rule. So 4 root of 1 over 4 root of 16. Well, 4 root of 16 is 2, right? Because 2 to the 4. So 2. What's 4 root of 1? 4 root of 1. Don't write this down. So square root of 4 is equal to, because 2 times 2 equal 4. So square root of 9 equal 3 because 3 times 3 is 9. So square root of 1 is 1 because 1 times 1 is 1. What's 4 root of 1? Oh, I bet. It's still 1, right? Because what? 1 times 1 times 1 times 1 is still 1, right? Go back there. Just kind of like these, right? 9, 4, 1. So n root, basically n root of 1 is 1, right? Because what? You take 1, you put it to the power of 9 is still what? 1, right? Right? Even 9 in the power, any number is still 1. So 1. Basically, root, you take root, any root for 1 is always 1. So 1/2. Okay, number 4, more, just slightly more complicated. Between 125 and 169, is there a common factor that I can reduce? I don't think so, right? 125 is divided into 5, but 169 is divided into, I don't know what it divided into. What's 13, I think, right? 13. All right, so I'm just gonna break it apart right now because I cannot simplify it. So square root of 125 n to the 7, and then square root of 169. You tell me what's the square of 169. You don't know? Use the table. Right there. Right, it's 13. 13. 13. Now the top, I have to break it apart. Do you remember the top now? It's kind of similar to what now? It's similar, you go back to the one we just did, right? To the previous section. Now you simplify kind of like these. I told you math is like a build-up thing. You gotta know the step before in order to do the next. So I'm gonna break it into a perfect square root and not perfect square root. So I'm gonna break it up into 2. This, the left one is a perfect. Sorry, yeah, the right one is not perfect. So one step at a time. 125. I can break it up into, well, you divide by 5. So 5 times what to give you 125? Is it 25? And 25 is, yeah, 5 square, right? Yeah, 5 times 5. So you only need 2 5s because square root. So 25 on the left. Are you back here? And then 5 on the right, right? 25 times 5 gives you back 125. What about n to the 7? How would I break that up? N to the 6 and yeah, and then just n to the first. Okay, so square root of 25 is 5. So square root of n to the 6 is yeah, 3. So n to the third. And then the left hand side, nothing, you can just rewrite it. Square root of 5 times n. And then on the bottom, rewrite the 13. I say we missed something. One more thing, one last little thing. Yeah, where? Yeah, n cubed. Right, because you start out with even root. Square is even root, even though there's nothing there, but you know that there's an invisible 2 here. Right? It's even root, you end up with exponent, you're gonna put the absolute value around it. Unless what do I say on the exam? Unless I say all variables are positive, then you have to do that. So that's when you don't have to care about the square root at all. But I didn't say anything, so you still have to respect the fact that it might be negative. Number 5, I put the star there because it might be a little bit, I don't know, maybe it's kind of the section we do next, not this section, but let's do it. Let's do it because we're about to do the next section anyway. Okay, so simplify one term at a time. So 3, nothing I can do, leave it alone. What's square root of 27? Hmm? 27. If you doubt yourself, write it out. 27 is 3 times 9, which is 3 times 3. How many 3 do you need? 2, right? You only need 2, so you have one more left. So so this is gonna be a what? So square root of 9 times 3, which is the square root of 9 times the square root of 3, right? Which is 3 root 3. What about cube root of 8? Oh, you done this before. What's cube root of 8 equal? Yeah, 2. Put this yellow. Oh, you cannot see yellow. So 2. Okay, I hope you guys don't stop here. You can combine the 3 and the 2, right? 3 plus 2 is 5. Then the other one, nothing you can do is just write it as 3 root 3. And you're done. So this is what we're gonna do next. I'll repost my 8.2 note. Okay. Okay, I want you to try it out. So 8.3 is simplify rational exponent. Before it was radical, meaning root. Now it's rational exponent. So it's exponent stuff like power stuff. I want you to rewrite 5 to the negative 3. Do you guys remember the rule that I told you? 1 over 5 to the third, right? Remember the rule I told you is I have a to the negative n is equal 1 over a to the n. You flip because this is a to the negative n over 1, right? You flip it, and then you've got the positive exponent, which is 1 over 125. What about second one? Again, there's another rule, a to the m to the n is equal a to the m times n. Now, if you have 2 powers, you multiply them. 2 powers, 1 base, right? Don't 2 powers, 1 base, and then the other one is 2 base, 2 power, then you add. So you see the difference? People, students get mistaken with between the two all the time, right? So they will do, so what they're gonna do is they're gonna add for this one and then multiply for this one because they see multiplication. Which is not true. It's not true. Multiply for the power, you add for the prime. So for number 2, you're gonna apply what? You're gonna apply the first or second? First, right? First. So what you do is you just distribute that 3 outside into each of a factor. So it's gonna be 4 to the third. Maybe I'll write 4 in black. Here, like this. Let me do like this. So next one will be x squared, right? And then they have the 3 outside too. And then y to the 5th. And then the 3 outside. Right? You distribute that 3 into each of the factor. Four cube is 64, right? X squared cube is, yeah, x to the 6. No, not x to the 5th. You want to multiply x to the 6 and then y to the 15. Okay, that's something that I want you to be aware of. Right now, we jump to the section. If square n root of a is a real number where n has to be at least 2, makes sense, right? If n is 1, then there's nothing I talk about. N root of 1 is 1. Then I have this rule: a to the 1 over n equals n root of a. You guys see this before? This is just the special case of the boot method. To remember this, I think it's up here, right here, the boot method. Oh, I don't have it here. No, the boot method. Boot method is a as n root of a to the m is equal to what? You kick the little m over. The boot, the winter boot. You kick the m over, it'll be what? A to the which one on the top, which one on the bottom? M on the top, all exponent all the way on the top, right? And then you have that rule, that rule, right? Same thing here. If I have n root of a, what a here under is going to be understood at a to the what power? To the first power, right? Because there's another. And then you use the boot method. You draw a little boot here. You kick that little 1 over. What do you have? You kick that little 1 over. Again, exponents all the way on the top. So 1 over n. So it's a special case of the boot method, right? Instead of a power of n, some power bigger than 2, than 1, you have power 1. So it's the same thing. You know, it's the best. Maybe I should say something like this. It's not a good way of saying it. It's to say, I want you to change to radical and vice versa. Okay, so first one, definitely it start out with exponents. I want it to be radical. So using the rule up there, how would I rewrite r to the 1/2? Okay, remember the exponent is on the top, always on the top. So exponent here will be r to the first, right? And then your index is the one in the bottom, the denominator. So it's actually square root, right? It's but nobody is saying 2 root of r to the first. So we rewrite it as square root of r. What about number 2? What do you think? Number 2. Which one on the top? Which one on the bottom? Yeah, so gonna be the root something of x to the first, and then what should I put here? 3, right? So it's the cube root, and then you can rewrite it as cube root of s. Just asking you to change things back and forth, back and forth. Okay, you got to be able to tell me what t to the 4 now. T to the 1/4 is equal to so there's a root, and then what the root, square root, cube root, 4 root, right? 4 root of t. That's it, 4 t. That's it. All right, so that's it from, so this is from, so these right here, right here is from radical, from rational. No, I would say from exponents, rational exponent. I don't have enough space. Rational exponent to radical. The last two will be, you do the opposite. You reverse engineer. Will be from radical, because given is radical, I want you to change into exponent, rational exponent. Okay, I'll do the first one. 4 root of 5 times x. So 5 times x, what the exponents of 5 and of x? 1, right? Is 1, right? So this is, I can rewrite it as, so again, no more, I want to change to exponent, so no more radical, no more that little root thing. So I'm gonna write 5x here, and then parenthesis. What on top? So for my exponents, what is the numerator? What is the denominator? Yeah. That's all. Just think one thing at a time. Don't think too hard. I think I'll stop here. Should I? I'm gonna distribute. If you want, you can distribute. So distribute. You use this rule again. This rule right here. And so 1 to the 4 go into 5. So 5 to the 1/4 times x to the 1/4. And then you're done. And then you're done. I want number 5. I want you to do at least for the first step, like I did in number 4, like number 4. Try from radical to exponent first. Don't worry about the simplification. Just try to change from radical to exponent first. I would say you can simplify it further, but don't worry about the steps. New stuff. Yes, good. That's it. That's all I. Yes. Good. Yes. Make sure you put parentheses around 9y. So that means the 1/8 is for both, not just for y, right? So equal, if I change the first step first, 9y to the 1/8, and then you distribute 9 to the 1/8 times y to the 1/8. Now on the exam, I see this a lot without the parentheses. So that means and then people forget. They just distribute the 1/8 to the y, but forget to distribute to the 9. Right, so make sure you put parentheses. Now I claim that I can, the y to the 1/8, nothing I can do. I don't know what is y, but I know what is 9. How can I rewrite 9? Are you black? How can I rewrite this one? It's the same thing as what? 9 is the same thing as 3 what? 3 square, right? So 3 square, and then outside you still have that 1/8. And then you apply the rule right here. Remember this rule right here, the one I the double check mark right there. You multiply those two power together, so it'll be what? 3 to the 2 times 1/8. Well, 2 is the same thing as 2/1, right? 2/1. Can you simplify the 2 and the 8, which is 4, right? So it'll be 3 to the 1/4. And now I can rewrite my answer is 3 to the 1/4 times y to the 1/8. To be honest, frankly, I think no, I don't know. I don't know. I don't know. It's easier for you to simplify with the rational exponent or with the radical. Depend. It depends on situation. Maybe radical most of the time. Okay, so let's see number 6. I have negative 1,000 parentheses to the 1/3. Depend how you want to do this. You want to turn into radical or you want to leave it and then do. So I'll show you both ways. I'll show you both ways. So the first one is method one. Method 1, negative 1,000 to the 1/3. So 1,000, I can rewrite it as what? Negative 1,000, wait, negative 1,000. It's the same thing as negative 10 times negative 10 times negative 10, 3 times, right? So negative 10 to the 3rd. And outside, you still have that 1/3. What should I do with the 2 powers? Multiply, right? So 3 is the same thing as 3/1. I suggest you do like that. So is this 10? Maybe use some blue. No, I want to use yellow because I'm gonna use blue later. And now you multiply the exponent. So negative 10 to the 3/1 times 1/3, 1/3, cancel, right? So it's gonna be negative 10 to the first power, which is negative 10. So that's one way. There's more than one way to solve these. How do I know which one I like? Just do a lot of homework. You kind of figured out what you're comfortable with. Okay, another way, method 2. Method 2 again, rewrite the question, negative 1,000 to the 1/3. I'm gonna get into radical. So 1/3, the power 1/3 is the same thing as what root? Same thing with what root? Cube root, right? Thank you, Taylor. Cube root. So cube root of negative 1,000 was to the first, but I'm not gonna write it. What cube root of negative 1,000? Well, the one negative 1,000, like I said, is the same thing as negative 10 to the 3rd, right? And then you can cancel. Cancel. So just negative 10. Which one you like better? Yeah, I don't need to be which one you like better? Second one, okay. All right. Okay, let's do second one from now on. Sometimes the first one is easier. Sometimes, most of the time, I think this method one is easier, but sometimes it's, I don't know. It's just depend on the situation. Okay. All right. So, number 7. Let me give you a little heads up. If you, the reason I have a the parenthesis and not the parenthesis because they're two different things. Let me give you an example. Don't write this down. Maybe you want, but if I have -2, all of that square is the same thing as what? -2 times -2, which is 4, right? So you have negative and parentheses squared, that means turn into positive. If I have -2 versus -2 squared, this means -1 times 2 squared. You agree? Now, because there's no parentheses, that means the power is not applied to the -1. So it's only applied to the 2. So -1 times 2 squared, which is 4, which is -4. So be careful. Okay, parentheses very important. You know, see parentheses, that means the -1 in front. So same thing with number 7 is kind of like the second case. So it's gonna be same thing as -1 times 1000 to the 1/3. And you want to change it into radical. So I'm going to change it into radical. So -1 times cube root of 1000, which is you good enough. You don't have to show me this step right here. But for the purpose of the lecture notes, I'm just going to put the extra step. So cube root of 10 cube, which is 10, right? So -1, oops, I meant to be black. -1 times 10 is -10. This is not a good example, but I should have do the square root. Oh, maybe number 8, number 9 be better. So for the odd cube, it doesn't matter there's parenthesis or not. But for the even root, it's gonna be a different, kind of like the case here, right? You have 4, -4. But for the odd root, not so much. The answer is the same. Because why odd root take everything, right? Okay, so number 8, how would you rewrite this? To tell me your first step. You like to turn into radical, so let's do that. So what kind of root here? Square root, cube root. Yeah, 4 root. So -16 to the first. Ooh, what happened? It's an even root. That's a number 4, not number 9. Let me rewrite it. It is an even root. And what do I say about even root? They only take what? Even roots are picky. They only take, as far as we're concerned right now, we only take positive or at least 0, right? So at least 0, nothing negative. So so up to this point, you're gonna say not a real number. Your answer is gonna be not a real number. So you're gonna say, if you see a negative under an even root, you say narn. Narn stands for not a real number. Later, we'll be able to solve this using imaginary number, but right now, none. What about number 9? Is it narn? Is it narn? So this one, tell me how I rewrite the first step. How would I rewrite this? Yeah, thank you, Taylor. -1 times 16 to the 1/4. And then we switch to radical, so equal -1 times 4 root of 16. Tell me what's 4 root of 16 equal? None. Curtis? 2, thank you. Yeah. So -2. So see the difference between the parentheses and not parentheses? for the even root. There's difference. Okay, number, how many do I have? Okay, not bad. Maybe I have time to, I'm not sure I have time to show you that little thing in adventure movie. It's math stuff. Maybe if not, I'll show you next time. Simplify the expression with a, so this one is simplify the expression with a to the 1 over n. Now is a to the m over n. Again, the boot method thing, right? The boot method thing. Just watch out for. So what I teach you, what I taught you is this is equal to this, correct? Boot method, right? M is going to be your exponent, n is going to be your index. And the same thing is you don't like to write like this, you can write it like this. They are the same. Like you want to put the m outside the whole root, that's fine. It's the same thing as the m inside the under the radical. What do I want here? Oh, okay. I want you to change. I want you to change to I want you to change to rational exponent and vice versa. So this one, if I want to change to rational exponent, will be what u to the what on top, what on the bottom? 2 over 5, right? Easy enough. At this point, you should be able to know. What about the second one? Don't think too hard. Just do the first. Could be what? 2p cubed. All of that. 3 over 5. And then you distribute. And then because there are multiple factors, you distribute. So 2 to the 3 over 5 times p to the 3 over 5 times q to the 3 over 5. And I don't think I can simplify anything, so I stop. Okay, so the first two is, again, this is radical. Did I do radical? Radical in blue. I want to change radical to rational exponent. I'm gonna use blue. All right, so the last two will be the last two is rational exponent to radical. All right, you tell me, how do I change this? Don't think too hard, just one step at a time. What index here? So there's a root and there's a 25, and now you fill in the index and the exponent. Index is 2, which we don't write, right? I'm just gonna put the little dash 2 here. I mean, it's a lot of times it's gonna be invisible. And then it's q. Oh, there's many ways to do this. Oh, there's so many ways to do this. Okay, 25 cube. I can simplify with the 2 outside, right? Maybe I'll show you the easier way, but let's just finish with this. So 25, how many 25 do I need to simplify? How many 20? 2 of them, right? 2 of them, because there's a cube. Yeah, I'm sorry, there's a square root. So 25 times 25, how many times? 3 times, but I only need 2 of them. I only need the 2, which is 25 square here times 25 here. Remember, I can break it apart. 25 square, come on, it's kind of lag. 25 square is so square root of 25 square. You can simplify that. So square root of 25 is 5. Square root of 25 square. So let me put a 2. Maybe if I put the 2 here, maybe you can see it, Kobe. What I can remember, I can boot method. I can take Yeah, 25, right? I keep the 2 over, 2 divided by 2 is 1, so 25. So 25 equal 25 times, what's the square root of 25? 5, right? So 25 times 5 is 125. I'll show you another one easier. Alternatively, 25, I can rewrite it as 5 squared. Is that okay? And then outside is 3/2. The 2 here is the same thing as 2 over 1. Now you can use the rule, exponents rule thing. You can multiply the power. So 2 over 1 times 3 over 2. The 2 cancel, right? This 2 and this 2 cancel. Oh, it's lagging. I'm so sorry. There you go. So now it's just 5 to the third. 5 to the 3 over 1. Which is 5 to the third. Same thing as 5 to the third. What's 5 to the third? 125. So like I said, it depends situation wise. If you do enough homework, you kind of know what you want to do in terms of choosing method. All right, last one. Let me ask you, last one. What do you like to do? You want to choose the red method or the black method? Yeah, the black, right? It's just easier. It's just easier. So let's do that. So let's do that. I'll use black. So 9 to the negative 3/2. So what should I rewrite 9? How should I rewrite 9? 3 square, right? 3 square, right? Now it only work, the black method only work if your number is the perfect square, like 9, 16, 36, stuff like that. And then you can, maybe you can simplify. So outside is still negative 3/2. Rewrite it. I always do 2 over 1. And now you multiply, so it equal 3 to the 2 over 1 times, let me put the 1 in yellow, times, on it. Oh, what happened? 2 over 1 times 3 negative 3 over 2. I don't know if that's okay. So now you simplify, right? The 2 here, the 2 here cancel. So I have 3 for my base and negative 3 over 1, which is 3 to the negative 3, which is no. If you have a negative exponent, you never have a negative number. It just what do you do? What rule? You flip, right? You flip. You have negative exponent, you flip. First thing you think, you flip. So this is same thing as 3 over 1, right? So you flip is 1 over 3 to the third. Now the exponents turn positive. So you almost correct, Corey. So it's equal to 1 over 27. Remember, negative exponent does not mean you have negative answer. Let's just flip it. So far, so good. Yeah, so far, so good. All right, last one. And then we finish everything. Yay. Okay, so here is, I give you the rule here. I wrote it like throughout the lecture notes. But here I just kind of copy from the book and then summarize it to you. You know this, right? Product turn into sum for the exponents. Here is power into product for the exponents. And here is this distribution rule. Remember, you distribute the power into each of the factor. Oh, this one new. I think I taught this once or twice before, but I never really actually do much about it. So a to the m divided by a to the n instead of multiply. So remember, quotient turn into subtraction, right, for the power. So you subtract n, keep the base, that's it. A to the 0 is 1. Basically, anything to the 0 is 1. Anything to the 0 power is 1. Anything, as long as inside the parenthesis is 1. Same thing here, distribution rule for quotient a divided by b is the same thing as a to the m divided by b to the n. Basically, you distribute. And here, this one, you have negative exponent, you bless you, you flip it and turn the negative exponent into positive, as long as it's not 0, right? That's the only thing you watch out for. Okay, so let's do this. Number 1, what would I use? What do you think I'm gonna do? I'm gonna distribute. You think? I'm gonna distribute. I'm gonna distribute. So I'm gonna distribute this one into each of the factor. So it's gonna be equal 625. Maybe I'll write left. Oh, like that. So 3, 4. Need some space. So 3 to the 4 here, and then 3 to the 4 here. So I distribute. Inside the parentheses will be 625, and then n to the a over 3. Okay, 625. Is there something that you can rewrite 625? You think? 5 to the what power? I don't have a, huh? Well, thank you. So the 5 to the 4. Let me do one thing at a time, so I don't rewrite everything. So let's do the number first. So 4, 5 to the 4, same thing, 5 to the 4 over 1, right? Let me write this. And then you just, and then using the rule, what rule was it? They call what was it? Power property. This one. You multiply the power. So 5. Oh God, it's really challenging keeping up thing. Color code wise. Times 3 over 4, which is equal to this one cancel. So 5 to the 3rd over 1, which is 3. 5 to the 3rd is 125, right? Okay, so that's 1. All right, let's take care of the letter n to the a3rd. Using power rule again, so be n to the a3rd times 3 over 4. Cancel. Oh, I can cancel the a and the 4 too, right? So we what? A and the 4 is leave me 2 on the top here. So n squared. N squared, which is n squared. It's n squared. Let me do number 2, just real quick for you, so you can do your homework. If I was you, I would take care of the top first, and then I'll take care of the quotient. So let's take care of the top. Why? Because they have the same base, right? If they have the same base, do I add? Do I multiply? What do I do with the exponent? Go back up. If I have the same base, right here, product property, right? I have the same base, I add the exponents and keep the base. So keep the base, which is keeps x, and I add 3, 4 to negative 1, 4. Again, I'm doing the top here. So what is it equal to? Negative 2, 4, right? Which is, you simplify that, negative 1/2, and then rewrite the bottom. Oh, the bottom, can I simplify the 6 and the 4? is gonna be what new power here? What common factor between 6 and 4? 2, right? So I can rewrite it as -3/2 x to the -3/2 x to the -3/2. All right, now I'm gonna look up on my table. I'm using quotient to the power property next. The next to the last one. Actually, no. I'm gonna use quotient property. My bad. I'm gonna use this one right here. That one. So I'm gonna take the top exponent, subtract the bottom exponent. That's what I'm gonna do. So equal x to the -1/2 minus -3/2. Minus become positive, so x to the -1/2 plus 3/2, which is 2/2, which is 1, which is x. And then that's conclude our lecture. Thank you for giving me a few extra minutes. I don't have time to show you the adventures video, short video. Next time. Easier if you guys are here when I show the things. All right, any question?